Hello everyone. Today we'll be talking about image segmentation in the domain of digital image processing. So let's start. So segmentation is the process of partitioning a digital image into multiple regions and extracting meaningful regions known as regions of interest for further image. The purpose of segmentation is to partition an image into meaningful regions with respect to a particular application. Application of image segmentation. The application of image segmentation include identifying objects in a scene or object-based measurements such as size and shape, identifying objects in a moving scene for objects-based video compression, identifying objects which are at different distances from a sensor using depth measurement from a laser range finder enable path planning for mobile robots. So let's look at some examples here. As you can see, the segmentation based on grayscale is there. A very simple model of grayscale leads to inaccuracies in object labeling. You can see as the pictures are depicted there. So let's take another example in which the segmentation is based on textures. Enable object surface with varying patterns of gray to be segmented. So now we'll come to the formal definition of image segmentation. If the subregions are combined, the original region can be obtained mathematically. It can be stated that union R1 is equal to R for I is equal to 1 to N. For example, if the three regions of R1, R2 and R3 are combined, the whole region R is obtained. The subregion Ri should be connected. In other words, the region cannot be open-ended during tracing process. The region R1, R2 and Rn do not share any common property. Mathematically, it can be stated as R1 union Rj is null for all I and j where I is not equal to j. Otherwise, there is no justification for the region to exist separately. Each region satisfies a predicate or a set of predicates such as intensity or statistics, that is, predicate P can be color, grayscale value, and other image statistics. So let's look at the classification of image segmentation algorithms. So there are two types based on user interaction and based on pixel relationships. So based on user interaction, we have manual, semi-automatic, and automatic. While based on pixel relationship, we have contextual, that is region-based or global, non-contextual, that is pixel-based or local. So let's look at the type of these segmentation algorithms. We know that there are two types, contextual and non-contextual. We just covered this. So what are the various segmentation techniques? If we look at a very simple image segmentation technique, the gray level histogram of an image can be done using threshold or clustering. So let's see what is threshold. One of the widely method used for image segmentation is useful in discriminating foreground from the background. By selecting an adequate threshold value T, the gray level image can be converted to binary image. Now, there is a mean technique, p-tile technique, histogram technique, edge maximization, and visual technique. So let's see what's the mean technique. This technique uses the mean value of the pixels as a threshold value and works well in strict cases of the image that have approximately half to the pixel belonging to objects and other half to the background. The p-tile technique uses knowledge about the area size of the desired object to the threshold of an image. The histogram-dependent technique separates the two homogeneous regions of the object and background of an image. There is a edge maximization technique and a visual technique also. So now let's look at the clustering techniques. So clustering technique is defined as the process of identifying groups of similar image primitive. It is a process of organizing the objects into group based on its attribute. The image can be grouped based on keywords or contents. Form a prompt which describes about the image keyword of an image referred to its different features. So you can see that there is an example shown here as the generic 3 into 3 spatial mask and the point detection mask. So let's cover point detection here. The point detection, the mask is superimposed onto an image and the convolution process is applied. The response of the mask is given by the shown formula where f of k values are the gray level values of the pixels associated with the image, a threshold value used to identify the point. A point is said to be at the location on which the mark is centered. So you can see that we have a line detection and what is the mask for these line detection using the formula. So let's look at the illustrations of line. So you can see that we have a building and then there is a horizontal line and vertical lines. So these are the detected lines. Moving to edge detection. If there is a steep edge, you can see the graph will be like this. The ramp edge, it will be a bit slant. And if there is a spike edge, there will be a small spike in between and a roof edge has a pointed stages in edge detection. So what are the various stages when we are doing detection in image segmentation? So we start with feeding the image, then filtering is done, differentiation, localization, display, end. So what are the type of edge detectors? So we have different type of edge detector, edge detection algorithm, derivative types, template matching, Gaussian derivative, pattern fit approach. Okay, now let's look at some of the first order edge detection operators, backward difference, forward difference, and central difference. So these are the first order edge detection operators. We also have the second order derivative filter. That is, you can see the different Laplacian mass is there and they are rotated and different variants are also there. So let's take another example of how Laplacian methods work. You can see the original image, that is the figure A, and the result after applying the Laplacian method. So I would like to conclude and summarize with the following points that segmentation is the process of partitioning the digital image into multiple regions. The main aim is to extract the ROI. It can be classified into three categories: manual, semi-automatic, and automatic. They can be classified based on techniques also, that is contextual and non-contextual. The edge is the set of connected pixels that lie in the boundary between the two regions. Pixel on edge are called edge point. Three stage of edge detection: filtering, differentiation, and localization. The objective of sharpening filter is to highlight the intensity transition. The thresholding produce uniform region based on three threshold factors. So I hope you have now some insights on image segmentation. Thank you for watching.